Okay. Oh, everything's good feeling to have everything working. Is everything really working? Barely. Just barely. I should check. Okay. Buddy's question here. Textbook. Okay. Textbook is up. Doing like check. Okay. And until then, okay. Let's get this done. Nice. Okay. Quotient real time. Font. Bad fun. Wonder how this will look. Hey, the room wasn't too bad on it. Point. I know I do this in a weird kind of slow matter, but it doesn't look too bad when it's done though. Mm, Healer. I know that there's a way to render. I don't really like the rendering, mostly because I don't know the language. But I should learn it anyways. But I like the way this looks. I don't have a lot to do. Just all of the derivatives. Prime. This one is a little bit different. I'll write it. B squared. Yeah, it doesn't look too bad. Okay. Merging time. What did I want to do? Chain rule next. Chain rule. What's a good way to write the change? Yeah, notation. Two notation. Or three. Three notation. Ah. Makes sense for the Leibniz notation. Or should I do prime notation's consistent. I should probably just do prime notation. Prime notation first. Okay. F of G. Do it all in one line. Yes. F prime. Of G X times G prime of X. Write the notation properly. F of G of X equals F prime of G of X times G prime. Yes. In Leibniz, dx is dy du times du dx. Yep, I'll do it too. Take a minute here. Why? Equals the snack that smiles back. What's the snack that smiles back? Come on. Dy du. Oh, goldfish. Wonder. Ooh. Does that look? Yeah, it will. Nice. Easy cheat. Yeah, you got time. Did you do question 2 yet? Why didn't you do question 2? You said you could do it. No, like this morning. You woke up a couple minutes ago. That's like 14 or 15 hours. It doesn't make any sense. When you sleep, you sleep. Okay. Okay, I'm just gonna quickly finish this up. Cool. Okay, let's see. What is it we're going to do? Travel the world, man. Travel the world. Okay. So we were on 4. The question is, do you remember how to do 4? Okay, so well, remember, so I want you to think about the question. Do you have the question in front of you? Because I'm going to take this away in a second. Okay, so remember what the question's asking. Okay, we're on B. And we've got g of x is equal to minus 4 cosine of 2x plus 7. Okay, it starts at 0. When x is equal to 0, finishes after 3 cycles. Determine the period, amplitude, equation of axis, main and range. Okay. So amplitude is 4, yep. Period is not 2. You're just, remember, what is the period of a regular cosine function? Your shift up is good. So hold up. Your period is not 2. It's not going to be the same. This is changed, right? Remember that the regular cosine function has what period? Nope. The regular cosine has 360. Our new one will be 360 divided by 2, so that's going to be 180. Just nice and concise. Yes, because we need 3 cycles. So 180 times 3 is what? 540. So 540 is the total length of 3 cycles, okay? So remember that the domain is from 0 until the end of the 3 cycles. So what's our domain? Zero to 540, yeah. What is our range now? Because that's the question. Range we had to kind of work out on the last one. Yeah, I don't know what you mean by XER. If you mean like X is in the reals, yeah. This is like X is in the reals such that X is greater than or less than whatever. My way is just a simple way of stating it. It's not the like 100% proper way. If you wanted to say that it's proper, you want X such that X is in the reals, or X is between 0 and 540. You know what I mean? No. Remember, we have to find the range. You're just trying to guess numbers all the time. Quit guessing numbers. We don't even need to graph it. We can just manipulate the numbers by starting. So remember that the regular cosine starts at 1 and ends at -1. Okay? But we're going to start changing that. We've got this -4 on front, right? And we have a +7. So we have to multiply whatever this is by -4. Then we add 7. Okay? So if we do the times 4 first, well, it's going to go from minus 4 to 4 now. If we add 7, seven plus 4 is 11, and then minus 4 plus 7 is 3. So our new range is from 3 to 11. That's just the simple way of just manipulating a number. No. What's 4 plus 7? You're not subtracting 7. This is a plus 7. Yeah, negative 4 plus 7 equals 3. No, you're not subtracting 7. It's not both negative 4. 1 times negative 4 is negative 4. Negative 1 times negative 4 is a positive. The range goes from negative 4 to 4. Then if you add 7 to those numbers, you don't minus 7. So think of it this way. Your first number is a 1. Then you times by negative 4, and you add 7. Your second number is a negative 1. You still multiply by negative 4, and you still add 7, because that's the equation. So negative 4 plus 7 is 3. This is a positive 4 plus 7. That's 11. Cool. You got it. So our range on this one is from 3 to 11. Yeah, 3 to 11. So now can you do the next one? Even easier. C is easy. H equals negative 1/2 sine t minus 5. Amplitude is a half. Just disable that button. It's driving me nuts. Shift down is 5. What's the period? Remember, you still need the period and the equation of the axis. We didn't even do the equation on the last one. It's the same. They haven't changed. The sine function and the cosine function always have a 360-degree period unless it is changed. This is just a regular sine t, so it's 360. Okay. Period is 360. So don't forget the equation of the axis. What? What are you talking about? Divide the period by amplitude. That has nothing to do with what we're doing. No. 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 Just no. Yeah, just slow down. You're trying to do things. You're just trying to like do math instead of like. No, what are we? Why are we dividing? There's nothing to divide. Just stop. Just stop. Relax. You're trying to do too many things without realizing what you're doing. Okay. First things first. What is the equation of the axis? Remember the equation of the axis? Yeah, just focus here. What is the equation of the axis? Do you remember at all? That's the better question. It's not going to be 5, because this is down 5, remember? Yeah, y equals -5. Make sure you write it as y equals negative. Okay? Now, I'm going to just assume that t is supposed to be an x because your teacher did e and c with the wrong variable. We're just going to assume t is supposed to be x. So we'll just assume it starts at 0 again. Now remember, it goes 3 cycles. So what is the domain of this function? Yeah, I can believe it. I mean, I take a bunch of questions from textbooks too, but I at least do them. Or do them first before I take them. Yes, the domain. Find the domain. No. No. Okay. The amplitude has nothing to do with the domain. Okay? Remember, the domain is how far it goes. We want 3 cycles. It doesn't matter how high it goes or how low it goes or anything like that. That's not the domain. The domain is all about how far it goes. 360 times 3. You got it. Remember, domain is the x value. 0 to 1080. Yes. Now we'll do the range. No, it's only because A and C didn't have a change in their period. B did, remember? Okay, so the question says 3 cycles. You just have to keep that in mind. And then a period is how long it takes to do 1 cycle. So you need 3 of them. Okay, so now the range. So a standard sine function goes from what range? Yeah, so I'm asking you, what is the standard range of a sine function? You can even look on the chart. Minus 1 to what? Like 1 sentence. Thank you. Minus 1 to 1. Okay. Now that we have the initial range, so sine goes from minus 1 to 1. Now we can change everything on here, right? So if we start at minus 1, minus 1/2 is the next thing that acts on it. And then we still minus 5. So what does that become? Yeah, so there's a minus 4.5. And what about the other one? It's 5.5. So what is the range of our sine function, our h? It will be from minus 5.5 to minus 4.5. See how that works? Do you see? Okay. You get it. So now, do you understand that we're doing like the logic and just the reasoning? Okay. Minus 9. So, this one is a little bit interesting because it's got this little 4 inside and a little horizontal shift. Now, I think I can make this relatable. And the amplitude's always in front. What number is in front of the cosine here? What do we always assume is multiplied by, but we just don't write it because it's tedious to write it? 1! Exactly. Yeah, he doesn't go into radians. I mean, you haven't done radians in this question yet. So anything on this assignment hasn't used any radians, so I guess we're just sticking with degrees. The funny thing is 2 pi is the same as 360 degrees. And it's just pi. You don't put an e on this version of pi. Okay, so let's finish this question here, bud. You've got the amplitude. What about the changes? Yep, shift down. So the only thing I would caution, because I was trying to flip through your textbook to see if they have anything written properly. But yeah, yes. And it's not left. Again, this negative sign does not mean left. What does the negative sign mean? Right. There you go. Shift right. Okay. What is the period? It's not going to be 360. Not at all. Already had it. Yeah, 90 degrees. Because your period is going to be 360 divided by 4, so 90 degrees. Okay. Now, what is the axis? Equation of the axis. And actually, like, write it as an equation. You did it before just fine. Where did you get 21 from? Like I don't know where you even got that number from. And write it as the equation, not just the number. What is the equation? Thank you. Okay. Now you need the domain. What is the domain? There is a trick to this one for the domain. Well, remember that x starts at 0. See if I can put this in perspective. How do I put a range in? Hmm. One sec. I want to think of something. No, I'm thinking of something else. Okay. Yep. 0 to 270. There. Good. And then what's the range? Where are you getting 21 from? Like, just where is that number coming from? How are you getting 21? What? This, remember, what does cosine give a value between? What is the regular range of a cosine function? Good. -1 and 1. Which means that this whole thing is just -1 and 1. So what's the range? Yeah, -10 and to -8. Okay. Do you think you could do the same thing again with D? Uh, Or with E. Could you do E and F? Like, can you follow the process and do E and F on your own? Okay. Okay, 5. Look at the reference sheet. I didn't put anything on any reference sheet. The range of the base function, I think that's what you're referring to. Good. Okay, 5. This one is like a logic one, I believe. So let's take a look. Two white marks are made on a car tire by a parking meter inspector. One mark is made on the outer edge of the tire. The other mark is made a few centimeters from the edge. Two graphs show the relationship between the heights of the white marks above the ground in terms of the time as the car moves forward. Okay. What is the period of each function, and what does it represent in this situation? So, period. Tell me about the period of this function. No, you only want one cycle. I count 4 cycles here. And it's not 10, it would be 1. Yeah. Because it starts at 0 here, goes up, and ends at 0. Then starts again. And starts again. Again. That's the big one. The black one. Or Mark 1. What about Mark 2? You write it down. Come on, bud. You're here. You're doing your notes. Come on. What is the equation of the axis? Well, do it. What is it? What's the period of the red one? Yeah. Same thing. It's just at a different point. It still does the same cycle. Yeah, I know what you mean by you haven't done it in years. So, again, what's the equation of the axis of each function? Well, 10. Yeah, you got to look at the question. Right here, 30 would be pretty good, I would say. That looks like a centerpiece to me. And remember to write it as an equation. So write y equals. Okay, what's the amplitude? What's the amplitude of the black one first? 4. Does it only go up and down 4 from 30? So 60 is the total height. So what's the amplitude? Yeah. And for the black mark, it goes from 30 to 60, and it goes from 30 to 0. So up and down is 30 degrees. Or 30 centimeters for this question. What's the amplitude of the red mark? So the amplitude is the range that it goes. Okay? The amplitude goes up and down and up and down and up and down. Equation of the axis is the center line between the two. So what's the amplitude of the red one? I'll be streaming as long as I can. As long as if people donate more money and stuff, then I can keep streaming. We'll see how it goes. I'll eventually either need to make this work or find a different job. I'm slowly getting bigger, but slowly is not quite enough. Yeah, it was debatable before, and now it seems to be working more steadily, so I'll be getting more consistent. I would always have trouble with the internet connection. Like some days, right now, it seems to be doing okay. Other days, I literally just could not stream at low quality. So I didn't want to just always say on my story, hey, I'm going live, and then just 5 minutes later be off because it doesn't work. Right? If I can keep it more consistent, then yeah. We'll see. It's funny that you say advanced. You need to redo a lot of this stuff, bud. You gotta start like thinking more math like, not so much just do the answer type. Anyways, what's the range of each function? This is super easy. – 0 to 60 for the black, and what about the red? Yeah. See, you got this. Then you need the speed. Now you said you even had the equation for the speed already. Ah, thanks for the follow, bud. Yeah. Because you do trig functions in calculus, you have to understand how they work and operate. Especially when you're going to start doing differential equations and stuff. Yeah, trig is pretty boring. I help with just first year stuff. Every once in a while I help with like second and third year stuff, but it's very infrequently because most of the time if you're up that high, it's like you don't need help, and I don't remember everything there is for upper years. Hard enough keeping track of everything in the world for even high school. No, I don't help with fourth year engineering. I didn't even do engineering. I haven't done physics in a while. I have a couple of textbooks, but I haven't done it in a while. So the question is, you said before the equation of the speed is 2 pi over the period, right? That's what you said before. Well, here's the thing. 2 pi is 360 degrees, and what did you say the period of each of these functions was? The period is not 30. That's the amplitude. What was the period? I believe it would be even higher than that. What did I say? 0.25? Not 1140, 1440. And yeah, it would be the same as 360 times 4. Let's see. What was 6? Oh, come, you can. You guys can do this one. Determine whether each function is or is not periodic. If it is periodic, find the period and the amplitude. So remember, the definition of period is how long it takes to do one cycle. So if it takes 0 to do one cycle, then it never cycles. Like, remember the logic there, bud. From there to there? I don't know, I'd say it would be over 4. I don't think it looks very periodic at all to me. Yeah. I know it hasn't learned every word yet. There's so many random math words that are taken as sexually. Like hump. Yes, that could be considered a sexual word, but in math it's not so much. The automod is basically for those random trolls that like to come in and swear a lot. Okay. 7, all you have to do is describe. How do you find the period of the multiplication of those two functions? I don't know, graph it. Okay. And 7 for FTW, all you have to do is just write a sentence for it. So I'll let you do that. For 8, find the amplitude and period of each function, then sketch one cycle. Well, that's the same as question 2 for you. What do you mean, how do you sketch it? We went through that before. Remember, all we did was take the base one and then just like add each little thing to it. And that's how you sketch it. Remember, take your base ones, the printout that I gave you, and then just manipulate it based on what you know. We'll do 3 sine 4x again or something. This was 8. 3 sine 4x. What was the amplitude? And the period. Nope, amp is not 4. 3, and the period will be 90. Okay, so let's start with the base graph. Sine. Sine goes from -1 to 1. And sine of 0 is 0. So, 290, 180, 270, 360. Yep. 360 divided by 4. 0, 90, it's 1, 180, it's 0, -1, 0. Okay, basic sine graph. Okay, 1 cycle. Then all you have to do is start modifying it, right? We could do the change by the 4. So 360 now goes to 90 degrees is 1. Okay? So then each one of these little tick marks that I draw gets divided by 4, just like 360 did. So 90 divided by 4, what? 22.5-ish. This hasn't changed, -1 and 1. I'm just going to go to 22.5. 55. Probably 67.5. Yep. And then 90. So if we were still going 360 degrees, oh, we're only sketching 1 cycle. Still starting at 0, but now everything's been compressed. So 90 goes to 22.5. 180 to 45. 70, 90. Still the same. Okay, but it would just be much more condensed. I just stretched it out numbers wise. Then the last one we have is just changing the amplitude to 3. So y equals sine x, y equals sine of 4x. Last one, multiplied by 3. So let's take a look. Pi over 4 is 45 degrees. Yep. Here's sine of 4x. 0. Pi over 8. Pi over 4. 3 pi over 8. Pi over 2. So remember that you divided the period by 4, right? To get 90 degrees for the total period. Okay. Remember your original, the base period. Exactly. Take each of the notches like I did. So these were all critical values that I already know. 90, 180, 270, 360. Critical values. Well, for me to just draw them, I took each one of those and divided by 4. 90 divided by 4 is 22 and a half. 180 divided by 4 is 180. Not 40, 90. So you take your regular sine one. Regular sine one. Okay, y equals sine x. That's this top one. Okay. Your regular sine x graph. The new period is, instead of being 360 degrees, it's 90 degrees. Like you said, you already found that out. Okay, so the whole thing for one cycle is only 90 degrees now, instead of 360. Okay? Following me so far? So what you did was you took the full period and divided by 4. So 360 divided by 4 is 90. Well, I took each other value that's critical for me to graph sine, which was 90, 180, and 270. Because those are the special values that it'll go through in the cycle. I divided each one by 4 because that's what you did to the period. Okay, so that's how these 4 numbers appeared. Okay, you have 360 degrees as your regular. Good? You got me there? The regular graph period is 360 degrees. Okay. The new period is 90 degrees. Yes? Good. What you did was took the full 360 and just divided by 4. Correct? Good. In the regular sine graph, 0 is 0. At 90 degrees, sine is 1. At 180 degrees, sine is 0. 270 degrees, it's minus 1. And then back, 360 is 0 again. So all I did was just divide each of those values by 4, because it's consistent, the exact same thing that you did before, just so I know what those points will be. Does that make sense? These are the initial values of sine. They are just this, the 100%, that's just the absolute values. If you plug a sine of 90 degrees in your calculator, you will get 1. If you plug in sine of 180 degrees, you will get 0. Like, that's literally the values. Type them into your calculator, you'll see. Yeah, 90, 180, 270. It's just the regular sine and cosine. 4 values. They're on the unit circle. They're on here. Where is the what I drew? They're on here. This is the unit circle one. Here, let's. What was the unit circle page? No, page 3? Yeah. Tan's different, but I don't think you're graphing tan. You're not even close to graphing tan. It's not scary. They're just numbers. Kind of like saying that 4 is 2 squared. That's just what the number is. 2 squared is 4. Yeah, that's all I did. That's how I got 22 and a half, 45, 67 and a half, and then 90. So now the last thing is just putting that amplitude in there. So instead of -1 to 1, it's going to be, what is it, 3? Yeah, 3. So just multiply by 3. So it goes from 3 to -3. Everything else stays the same. Right? You just have to go from the original, manipulate it a little bit, each little step, and you'll wind off with your function that you need. Yeah, easy. You should be able to do the rest of your assignment, no problem. I think you're trying a little bit too hard to explain something that doesn't need explaining. Like, the number 1 was what we had originally, and then we just multiplied it by 3. You know what I mean? You can't say that you literally just want to pass, because you're going to take more next year, right? You can't just pass. Just passing is not good enough. You need to understand. Think more about just understanding rather than just passing. So which piece do you want me to explain? The 3's on the side. Okay. Remember that this 1 to -1, all this stuff, all this line is the output of sine of 4x. Okay? Sine of 4x. So this right here is a number between 1 and -1. Okay. If we just multiply that number by 3, because the 3 is on front, we're literally just multiplying by 3. Well, 3 times 1 is 3, and 3 times minus 1 is minus 3. You see how that worked? And then since there's no other shifts in this, you know that it's just going to be 3 to minus 3 because that's the amplitude. Cool? Cool, cool, cool. But you should be able to do these. The rest of these is all just to determine the amplitude and the period. For number 2, it's all just find the amplitude and period. You can do that in 10 seconds. And then 8, the second one in 8 is, again, the same thing as this. You just kind of label it and graph it. You should be able to do this all on your own, bud. What is it? Chapter 5, number 1 assignment. I will look. Chapter 6. Probably saved it. Here. We got 2. Assignment 2. Okay. 2B and C and 3B. Okay. So the question is basically just exact values. 2B. 1 minus tan of 45 degrees times sine of 30 times cosine of 30 times tan of 60. So we did this before, and I told you that it was very simple, and we did one, and I was like, okay, you should be able to do this now. Oops, all of them we know. Okay, I sent you this reference page. This reference page. In it has the trigonometric functions of special angles. Okay, it's this little thing right here. I can even bring it up on here. What is that, page 2? Yes. See this right in here. This is all you need for that question. Literally all of it. So, let's work through it. 1 minus tan of 45 degrees. What is tan of 45 degrees? Tan 45 degrees, 1. Oh, that was easy. One minus 1 is 0. Which means what 0 times whatever the rest of this is 0. Well, that was quick. Okay. Let's see, what else do we have here? Do they really just want... Yeah, tan of 45 is 1. Wow, that's hilarious. Tan of 30 degrees. The C question. Tan of 30 degrees. Plus 2 times sine of 45 degrees. Cosine of 60. Okay, but tell me this now. Resend the... You didn't print them off? I it's sometimes. Yeah, I'll be around. Look, see? Erdy knows what's going on. See, the thing is the answers are literally in front of you. So it shouldn't be too hard. Tan of 30 degrees. When you rationalize, it's root 3 over 3. Plus 2 sine of 45. Root 2 over 2. Cosine of 60. Well, that was what? 1/2. They're on the sheet. I sent you the sheet. They are the exact values. Literally right here. There's this table right here. On page 2. This table right here, page 2. You see it yet? Yeah, it definitely does. It's very easy to learn even how to just make these trig angles. Like the two triangles above it with all the trigonometric ratios tells you exactly how to get these. Sine of 45 degrees. Sine is opposite over hypotenuse. So 1 over root 2. See what I mean? Boom, bang, done. The whole reason I made reference sheets is for people to actually have a reference. I still gotta finish my derivative one, and I gotta start on the integrals ones. All other 6 or 7? All other 6 are done. So, to finish this off, all you have to do, simplify, combine like terms. If there are any, or find a common denominator. What do you mean, how do you do that? How do you add fractions? 2 divided by 2. Well, that's gone. We have root 3 over 3. Yeah, I can do that. Root 3 over 3. Do not use a calculator. Never use a calculator. People do it wrong every time. Calculators do it wrong every time. Root 2 over 2. Common denominator. We've got a 3 and a 2 on the bottom. Common denominator means you need like 6. 6 is a common denominator. So you'll multiply by 2 on the top and bottom. And 3 on the top and bottom. Which gives you... This is 6. This is 6. So it's over 6. 2 root 3. Plus 3 root 2. Done. They're the same thing. It's just a different notation. Cubic root of x different from x to the 1/3. It's the same thing. It's just a different notation. Same thing with square root and x to the 1/2. It's just a different notation. Again, so this one. This 3 thing. So cos, I'm just going to say theta. -7 over the square root of 53. And they say 360 degrees, which is bad. It's notation. Cubed root of x is x to the 1/3. So when it comes to this cos theta on our reference sheet is what? X over R, right? You have to do 7. No, it's 7. You already said that. We went through 7 before. So 7 says Jeff found 3 angles, which is cos theta is 4 over 5. Is it possible? Can theta have 3 angles that are equal 4 over 5? I'll give you a good hint. Exactly, you can't. In one cycle, it can't. The reason why is the unit circle right here. Right here. Four over 5. That's 0.8. We'll say it's over here. It's up here. It's positive. This is positive. There's only 2 places that this line is positive for that number. So it can't have 3. It could have 3 if it goes around another time. So if it had more cycles, it could have 3. If you're referring to, okay, Arsamaru, if you're referring to like manipulations, then yes, there would be a difference. But notation-wise, there is no difference. It's like you just kind of write it, they are the same thing. However, if you're going to say, so here, for example, let me bring this back. For example, if I say y equals x squared, and then we square root it, right? We can have, or no, I'm not going to say that. If we have a number that's just x squared, and we square root it, no, how do I want to say this? Not x squared. I want to just say x first. If I have a number x, and I take the square root of it, let's call it a, then this is going to be a plus or minus, right? Okay. Because you have 2 possibilities that when you square it, it becomes that number. So a squared is x. That's not how I want to say it. What do I want to say it? Y equals x squared. Yes. Okay. Then if we square root it, we'll have the square root of y equals x, right? But we need plus or minus. Okay? If instead of saying y equals x squared, and we start with y equals the square root of x, we are only interpreting the positive portion. Okay? If we start with y equals x squared and square root it, we have both a positive and a negative portion. If we start with just the positive square root, and then we square it, so that we would get y squared equals x. Yeah, you just can't have an additional size because this was only incorporating a positive portion, not a negative. Otherwise, just notation-wise, square root of x is just x to the 1/2. Or the cubed root of x is just x to the 1/3 for notation purposes. It's about describing what happens when you do certain operations. Anyways, did you have any other things you needed to do? Bud? 3B. Didn't do. Okay. Okay. I'm gonna say, I told you to do this before. You could have done this before. Why didn't you do it? Cos theta equals -7 over the square root of 53. What is cos theta on a reference sheet in terms of like x, y's, and r's? X over r. Good. Can r be negative? No, r cannot be negative. R is the length. Cannot have a negative length, which means x is negative. Okay, this implies that x is equal to -7 and r is equal to the square root of 53. Does that make sense? Good so far? Okay, we're still missing another value. We're missing y. How do we find the third value? Come on, stand track. It's really quick and easy. This is literally like 4 minutes tops. Okay, how do you find the third value? How do you find the y? Yeah, but that... No. Pythagorean theorem. No. Pythagorean theorem. Because that does not make any sense. This is cos theta. Right? Pythagorean theorem. x squared plus y squared equals r squared. So we need to find all the trig ratios for this cos theta. Here's the first one. We need the other 5. We have x and r. We need the third value y. We can find that by using the Pythagorean theorem. So, Pythagorean theorem. X squared, well, we've got minus 7 squared. Y squared, we don't have, so y squared. R squared, so square root of 53 squared. Make sense? So, 49 plus y squared, 53, y squared equals 4, y equals, this is where we would say plus or minus 4. However, there is a screw up in the question. Yes, 2. There is a screw up in the question because they said theta is between 0 and 360 degrees. If they say it's between 0 and 360 degrees, then there's not just one value for y, there's 2 possible values. If they had stated whether it's going to be in the between 0 and 180 or 180 between 360, then we would have one single value. Let's just assume they mean the positive y value. Are you following me so far there, bud? So do you know how to get the x value, the r value, and then the y value? Okay, good. Now, all you have to do is fill out the other 5 trig ratios. Hilariously enough, all other 5 are right here on the reference sheet. So just fill in the numbers. Sine is y over r. Cosine, we already have, is x over r. Tan, y over x. Just go down the line and fill them all out. R over y. Secant. R over x. Cotan. See what I mean? X over y. So, like, this is a question you should have done last time. When we did this before, you should have been able to finish this on your own. Because we even went this far. And I just told you to fill them out. Like we're doing now. And yeah, I'll send the 3 pages we have. You can go get your food now. Because I don't think there was any more that we needed to do. Okay, later, bud. Let's save each page. What's the date today? 5/20? What's the difference between the hyperbolics? Simple way to state it by just graphing them. And their exponential interpretations. So give me a second here. I'm just gonna send these 3 pages. Page. Okay. E minus okay. A good question. When should I finish? I do think I was going to work on some other stuff and maybe record a video. Because I have this other kid in Kashmir that wants me to do a video on inverse trig functions, but like inverse trig functions that we don't even bother with. So I have to like write a bunch of notes on it. And then I was also, so like I was doing these reference pages before, this one, I was working on the derivative one. And when I'm done with the derivative, I'll be doing the integral. So I'm not entirely sure when I'll finish. I may just stop. Unless there was like stuff to work on. But integrals and derivatives. Question is what though? Like, I'm assuming you've finished a calculus course, multiple calculus courses. Integral of e to the x squared. Let me guess. That was the. I think Black Pen, Red Pen did one on that? No. Oh yes, the error, the square root of pi over 2 with the ERF of f of x. The Gaussian function. Yeah. Well, a good question. 247, so it's almost 3. Probably have to go to yard. I think I'll have to stop now and go outside. Because then I'll have to be up and doing this again tomorrow, and I have other things to prepare. So I think I'll have to end streaming now or within the next few minutes and then do other work. You have to go study English? Have a good one, bud. I think I should be done for now too. I'll catch you later. A second language? What's your first language? Turkish. Very nice. Very nice. I'll see you around, bud. Have a good time.